So in this lesson, we're going to be starting our conversation about a very important topic in chemistry called stoichiometry. And so that is a new word, so I'm going to help you understand what it means. So basically, when you're talking about stoichiometry, you're talking about looking at a chemical reaction and making some calculations around that. And so we've already investigated how to interconvert between moles and mass values, and moles and pressure and volume values. But now we're going to look at those calculations in the context of chemical reactions. So before we get started, there's some common understandings that we need to have about what it is that what we can possibly do, or how we can possibly interpret this chemical reaction, and what we cannot do. So first of all, I think we can all agree that when we look at a balanced chemical equation, that these coefficients here can mean certain things, right? It's a proportional relationship here. Just like any kind of, if we were looking at a recipe to make a particular substance, we would need to have we have to be given the proportions of each substance that we're using. So in this case, it's reasonable for us to assume that those proportions can be in units of molecules, right? So 2 molecules of sulfur dioxide plus 1 molecule of oxygen gas plus 2 molecules of water can give us 2 molecules of sulfuric acid. And if we count out the atoms, we've conserved atoms on the product and reactant side through this reaction. So we also know that 1 mole of any substance is equal to 6.02 times 10 to the 23 pieces, right? That's Avogadro's number. And so if we multiply, we can do the easy conversion here, and we can also assume that each of those coefficients can also be interpreted to mean moles. But really important for us to know is that we can't assume that those coefficients are interpreted as grams, right? We know the law of conservation of matter means that we're not creating or destroying matter through a chemical reaction. So let's just do this test. If I were to, assume that these coefficients were in grams, I'd have 2 grams plus another gram plus another couple of grams, and I know that that does not equal 2 grams on the other side of this reaction. And so important to understand that the ratios in those balanced chemical equations are given in moles or molecules, but in our case, we're going to think of them as being in moles, but not grams. And the reason for that is that each atom, per the periodic table, has its own individual atomic mass, and that's going to influence the mass of particular molecules. Okay, so that's our good start. So now I think we're ready to start framing out how we approach basic problems that we might see in stoichiometry. So let's take a look. Okay, so here we have a pretty simple stoichiometry question to start us off, to scaffold us to some more challenging questions. And this will help us learn the basics. So in this example, let me read it out to you. How many grams of copper must be reacted in order to produce 5 grams of silver? And they give us, in this case, they give us the reaction equation with the reactants and the relevant products. And I've left out subscripts because it's not, it just adds another layer that we're not really concerned about in this question. And so I tend to, and this is my personal preference, but what I like to do is I like to write out sort of my givens just below where they fall in that chemical reaction if it's given. So for instance, I'm seeing that I am producing 5 grams of silver, so I tend to like to write out that 5.0 grams right below. And then my unknown, the thing that I'm looking for, are the grams of copper. So I'm going to go ahead and just write a law. This is how I do it. And I'll write in the unit of measurement that's being sought. So one thing I'm hoping that you're noticing right now when you look at this equation is that it's not balanced. And so whenever you're doing a stoichiometry question, the first thing you want to make sure that you do is that you balance that equation. Okay, that's why we practice that in grade 9 and grade 10 and grade 11. So we need to balance the equation. So I'm going to go ahead and do that. And if you need to see a video to explain that, then I would suggest you look that up before, because that doesn't fall in the context of this video. And so I see that I have 2 chlorines on the product side, but only 1 on the reactant side. So I'm going to go ahead and put a 2 in front of that compound, the AgCl. And so that changes the amount of silver that I have on my reactant side. So I need to fix that on my product side. And now I see that all my atoms are in good balance. Okay, now, given the conversation we just had about the coefficients in the balanced chemical equations, we know that that's really telling us is that for every 1 mole of copper and every 2 moles of silver, I can make 1 mole of copper chloride and 2 moles of silver. But I'm given values in mass, in grams, right? Because, those are easy to weigh out. It's a practical way of measuring matter in a lab. But I can't work in grams. So my next step in any stoichiometry question is to convert to moles. So I'm going to convert to moles. And in this case, the way that I'm going to convert to moles is using our formula that my number of moles, in this case it's silver, is equal to my mass divided by the molar mass. Okay, and so the mass of silver is given to me as 5.0 grams. And the molar mass of silver, I can certainly look up on my periodic table, and it is 107.87 grams per mole. And so that tells me that the number of moles that I have of silver are, let me just quickly work this out, 0.046 moles. And if I'm going to keep that value in my calculator unrounded, so I'm just going to write in don't round. Okay, we don't want to round until the very end here, but I am writing down with 2 significant digits, just keeping in mind that my 5 grams has 2 significant digits as well. Okay, and so the next thing I'm going to do is I'm going to look at something called a mole ratio. So I'm going to call this step number 3 over here. Okay, and so the next, I know from the proportions in this reaction that for every 2 silvers that I make, I needed to use, and so, I'm going to need 1 copper for every 2 silvers that I make. And so that's just, think about that like in terms of a recipe, right? It's just telling me the quantity of each ingredient that I need to make a certain amount of my product. So this is how we want to set it up. So I'm just going to call this is just analyze our mole ratio. So this is our mole ratio. Remembering that those coefficients in the balanced chemical equation can be interpreted to mean moles. And so I know that I have 0.4, let me correct that. I've got 0.046 moles of silver, but I don't want moles of silver. I want moles of copper. So I need to get rid of my moles of silver, and I want to keep moles of copper. So I know that I have 1 copper used for every 2 silver that are created. And so working that out, hopefully you have your unrounded value in the calculator. And so I'm going to stop at this point and just look at, we always want to be thinking about common sense here, right? It should make sense to you that because there's a 1 to 2 ratio between these 2 substances, that basically, if I know the number of moles of this guy, then the number of moles of copper should be half that amount, right? So that's just common sense. And so if the numbers are nice and friendly, that's a quick kind of mental math piece that you can do. But the ratios are not always nice, friendly numbers, so that's important, of course, for us to remember. Okay, so the next thing that we need to do, because, of course, in our question, we were asked to find out the mass of copper. Measuring out moles is a difficult thing to do in a lab. It's not really practical, and so it makes sense for us to want to convert back into grams. So that's the final step. And so our final step is going to be to convert to grams, and we know how to do that, right? So since I'm looking at grams of copper, and I'm just going to move this up here. So here we go, just so we have a little bit more room to do number 4. And so I know that I can get the mass of copper by taking the number of moles of copper and multiplying that by the molar mass of copper. And so I know my moles, 0.023 moles. And I'm going to look up the molar mass of copper, which is 63.55 grams per mole. And so multiplying those two values, I get a value for my mass at 1.5 grams. And that's, of course, to 2 significant digits. So overall, I was able to figure out that my mass of copper was 1.5 grams. All right, so that's your basic stoichiometry problem. So that is one approach, and notice that I broke that down into steps for those of you that really like to use steps. I'm also going to take a look at another way to solve this problem using unit analysis. So if you were really good at unit analysis and you prefer that method, this is just another way to go about this problem. So I'm going to clean the slate, and I'm going to do that again. And so the approach would be the same for the most part. I'm just simply going to balance. I always want to balance. And again, I like to write out my quantities, my required to find as well. But then instead, I'm going to just use dimensional analysis for this. So again, if this method doesn't work for you, that's fine. This is something that we've discussed in class and I've taught in previous lessons. And so it's not the place in this video for me to go there. But let's give it a go. Okay, so here's what I would do. I would say, well, I am starting with 5 grams of silver, but I don't want grams of silver, so I need to be able to cancel them out. So they need to go in the denominator here. And so I know that I can convert between grams and moles by using molar mass. And so I know that 1 mole of silver is equal to 107.87 grams of silver, right? And so in doing that conversion, I've converted to moles of silver. And I can think about, if I want to, at this point, I can cancel out my grams. And then I would be left with, if I stopped here, moles of silver. But I'm going to keep going. And so now I say, well, I don't want moles of silver. I'm trying to eventually get to copper. So I'm going to convert from moles of silver. I'm going to get rid of my moles of silver down here. And I'm going to replace that with moles of copper. And so what does my balanced chemical equation tell me about that? It's telling me that I forgot to balance fully, and so I'm going to add another 2 here, just as I did in the last problem. But it is telling me that I have 1 mole of copper for every 2 moles of silver. So there we go. I'm going to cancel those moles out, and now if I stopped at this point, I'd have moles of copper. But of course, we want to have that into grams, and so I'm going to keep going. And so now I need to get rid of moles of copper, and I'm going to replace that with grams of copper. And I know 1 mole of copper has a mass of 63.55 grams. That's my molar mass, grams per mole. And so at this point, now I've canceled out my moles of copper, and I should be left with grams of copper. This is the only units remaining. And if I go ahead and I multiply across and I do my unit analysis, 2 significant digits, this has 5, this has 4. So my answer should have as many as the value with the fewest. So I'm comfortable rounding that to 1.5 grams. Okay, so those are 2 methods that you can use to solve a basic stoichiometry problem. I'm going to move on to the next example, and I'm going to suggest that you pause the video and give it a go before you look at my response, just to kind of gauge where your understanding is, because you get the most out of the problem if you do that. Okay, so let me read it through with you so you can get started. It says, how many grams of oxygen are produced from 10 grams of potassium chlorate? So pause the video now, give the question a go, and we'll come back and solve it together in a moment. Okay, so let's do this. So as always, I really like to go ahead and balance first. So I'm going to go ahead and do that. And so I see that I have 3 oxygen on my reactant side and 2 on my product side. So I'm going to go ahead and put 6 as my common denominator here and get 6 oxygens on both sides. But that affects my potassium and my chloride count, so I'm just going to go ahead and add that into balance. And so I know that I'm saying, well, I'm using 10 grams of potassium chlorate, and I want to know how many grams of oxygen gas I might produce. And so that's a bit of a weird situation, because normally I would want to measure in terms of volume. It seems to make more sense. But in this question, we're going to use grams because that's what's being asked. And so I've balanced, and so the next thing that I want to do is I'm going to want to convert to moles. So I want to know moles of potassium chlorate. And so I'm going to take that 10 grams. I'm going to divide that by the molar mass of potassium chlorate, which is 122.55 grams per mole. And, you know, just to remind you, on the periodic table, I'm looking at the atomic mass of potassium, chlorine, and 3 oxygens. And I add that up, and that should give me that molar mass. And so the next thing that I want to do, once I have that value, which I'm going to calculate right now, to be 0.0816 moles, and I'm going to leave that at 3 sig figs, but I'm not going to round it on my calculator, but I'm going to write it with 3 significant digits because of that 10.0 grams. Okay, and so the next thing I'm going to do is I'm going to do my mole ratio. And so I know that I have, let me just write this out here. I know that I have 0.0816 moles of KClO3, but I don't want moles of KClO3, so I'm going to, you know, put them in the denominator to cancel them out. I know that I have 2 moles of KClO3 for every 3 moles of O2, right? And so that ratio helps me to know that I have 0.122 moles of O2 that would be produced. And so, you know, I've got moles, but the question is asking me to figure out grams. And so my final step here is going to be to say, well, my mass of O2 is going to be my number of moles times my molar mass. And so I have 0.122 moles times the molar mass of O2, which happens to be 32.00 grams per mole, right? 16 times 2. And so that's going to give me my answer to 3 significant digits, which is 3.92 grams. So hopefully you did okay with that. I'm going to go ahead and take this up using dimensional analysis. So stay tuned, and I'm going to show you the alternate way of solving this. So again, we're going to take a look at this question and balance it. So I've got 3 oxygens and 2, my mistake, I've got 2 potassium chlorates. And so with 10 grams of potassium chlorate, I want to know how much oxygen gas I can expect. So starting off with what I know, which is the 10 grams of potassium chlorate. I don't want grams of potassium chlorate, so I'm going to cancel those out. And I know that 1 mole of this substance has a mass of 122.55 grams, right? That's just using the molar mass of that substance. So I've canceled out grams, and I'm into moles of KClO3. But I don't actually want that. I need to figure out how many grams of oxygen. So to do that, I'm going to want to use my mole ratio at this point, right? So I know that I have 2 moles of KClO3 that are used in order to make, I don't know what happened to this 3 there, but there it is, 3 moles of oxygen gas. And so at this point, I've converted to moles of oxygen. And so I'm getting there, but I'm not there yet, right? So now what I need to do, and this is moles, by the way, what I need to do now is get rid of my moles of oxygen and convert that to grams. And I know 1 mole of oxygen has a mass of 32.00 grams. And so multiplying across, I should get the same value as I did before, 3.92 grams of O2. And by looking at this, I can see my significant digits here are 3. This is my other measurement. Here's another measurement. So the measurement with the fewest significant digits is that 10.0 grams. So I'm going to round to 3 significant digits in my response. So hopefully you found that okay. If you're a student in my class, then you will be assigned a worksheet to help you practice this. And I'm going to strongly encourage that, simply because these questions provide the foundation for a whole host of other types of related questions that we're going to see as we progress through the semester. So well worth it to invest the time in mastering this. Reach out as always if you have any questions.